Hi, my name is Keaton Ramja, and my project this year is on a comparative study between macrophytes, South Indian islands, and Surabaya and Immersion for remediation of common nitrate contaminants. Nitrate contamination has main causes including the overuse of fertilizers and leakage from water pipes. The nitrates that are in these chemicals can then seep into our groundwaters and aquifers, and unless this water is properly purified and filtrated, it is not safe for human consumption. However, these methods are expensive and they are not readily available in third world countries. Unsafe levels of nitrate in water can lead to damages in human and other organisms. Nitrates play a role in many diseases and disorders such as stomach cancer and blue baby syndrome. It also has the ability to turn hemoglobin into methemoglobin. And the problem with methemoglobin is that it does not sufficiently circulate enough oxygen throughout the bloodstream. The difference between hemoglobinemia and blue baby syndrome is that in blue baby syndrome, the nitrate contamination level in the human must be is at a lower concentration, and the side effects are visual as the baby's skin will turn blue. So, Cedomarsum, or the common thornwort, was chosen for this experiment because no previous research had been done with nitrate contamination when grown in natural settings hydroponically. It's prohibited in Australia because it is an invasive there, but it is native to North America, South America, and Eurasia. It is often used in aquariums since the leaves are known to oxidize the water and prevent algae and other contaminants from coming into the water. In a study done in 2005, it has been shown to greatly reduce the amount of nitrate when grown hydroponically. Essenadins, or the floating fern, was chosen for this experiment since no previous research had been done with nitrogen contamination when grown hydroponically in natural settings. It is native to Africa, Asia, Central Europe, and South America, and the anatomy of the plant allows safe breeding ground for fish, but prevents photosynthetic processes from happening underneath with other plants because of the way how the leaves fan out on top of the water and prevent light from going through. In a recent study done in 2011, it has been shown to have strong heavy metal absorption qualities. So from a rationale, as the price of filtration and purification processes increase year after year, they become less and less readily available in third world countries. These naturally occurring plants shown to reduce the amount of nitrate to below 10 milligrams per liter EPA standards when the water should be safe to drink. And this is a cycle. This is a picture of the nitrogen cycle, basically saying that how nitrogen is recycled throughout the environment. It is taken in from the soil and is eaten by animals, plants, and when these organisms die, they are redistributed back in the soil, or they end up in the atmosphere when it rains, it goes back down. So for my methodology, each tank was filled with 10 liters of distilled water, and plants were kept at the same weight of 12 grams. Nitrate was measured with an analytical scale, and all tanks would be given 12 hours of light and 12 hours of dark. So measurements were taken once in the morning and once in the evening using an EZ-Link system with a nitrate ion sensitive electrode probe and a TI-84 graphing calculator. Measurements were taken 5 times, averaged out, and then put into a data table, and this process would be repeated for 5 days. As a result of my experiment, the most successful treatment in the control trial was the Cedomarsum. Any fluctuations in the amount of nitrate might have been there prior to experimentation, since I bought these plants from a third-party seller. And they may also have been from other outside factors such as lab conditions, and as many organisms would enter my tank, such as fruit flies. In the 10 milligram per liter trial, the most successful treatment was the combination. Certain peaks, such as the 36 mark and the 96 mark, show photosynthetic peaks, meaning that during photolysis, when the water was taken into the cells, nitrates would also be taken in. And the nitrogen in nitrate would then be used to make a variety of organic acids and proteins. For the 20 milligram per liter trial, the most successful trial was the combination again. Again, there were peaks at 36 hours and 48 hours. For the 30 milligram per liter trial, the most successful trial was the combination trial again. However, the most amount of nitrate was removed by the SNMs at the 96-hour mark. For the 40 milligram per liter trial, there was a tie between the SNADs and the combination, and certain peaks such as the 60 from the Cedomarsum were due to photosynthetic processes. For the 15 milligram per liter trial, the S9s and combination trial treatments were the best treatments. This combination and the S9 trial were the best treatments as a result of this trial. The poor remediation rate of the Cetomerson may have been due to other external factors or the poor health condition of the plants prior to experimentations and about these plants specific on selling. So for my conclusion, all the tanks that received treatments of S9 and Cetomerson in the combination trial reduced the amount of nitrate to below 10 milligrams per liter. Nitrates are important in the construction of proteins since the nitrogen in these nitrates are then used to make organic acids and peptides and proteins when they are taken in during photolysis, and then they are used and broken down by enzymes. Some error in efficiency in denitrification efficiency may have been due to the poor health condition of the plant and any outside factors and lab conditions such as organisms entering my plant, like fruit flies. So for my future works, I would like to be working with other plants in the same genus as Salvinia and Ceratophyllum, such as Salvinia rotundifolia and Ceratophyllum incinatum. I'd also like to use Salvinia nidus and Ceratophyllum demersum for remediation of heavy metals such as mercury, zinc, arsenic, and iron. I would also like to use S9 and Cetomersum for remediation of nitrate on a bigger scale or an environment that has been deeply affected by nitrate contamination. One last thing that I would like to do is do a dry plant assay, which is where I would dry the plants using a convection oven, grind them up, and then make a solution out of the plants and measure the total amount of nitrate that has been removed. These are my references and my